And today I'm going to detail how vitamin D protects the brain both during and most especially after a traumatic brain injury, and also some easy ways to optimize vitamin D's performance in the brain and elsewhere. And when I talk about all the ways that vitamin D performs, you should remember that I'm actually referring to vitamin D's steroid hormone form known as calcitriol, which, as I've detailed numerous times before, requires magnesium for its activation. Because without magnesium, any ingested vitamin D from sunshine, food, or supplements stays in the liver as the storage form calcidiol. So once again, when you take your daily vitamin D, always remember to pair it with magnesium. Now that you understand that, let's get into what happens during a traumatic brain injury and how vitamin D can help. Immediately following a traumatic brain injury, microglia, the scavenging glial cells that ordinarily clear the brain of metabolic waste, release pro-inflammatory cytokines, leading to neuroinflammation. And while this inflammation is initially helpful for mobilizing immune cells to the site of injury, neuroinflammation can persist for years after the actual injury, and it's this ongoing neuroinflammation and related neurodegeneration that can contribute to widespread tissue damage, neuronal loss, and overall neurological dysfunction. Vitamin D receptor proteins are widely expressed across multiple brain regions, including neurons and glial cells. And active vitamin D, again also known as calcitriol, is a steroid hormone and also a neurosteroid that maintains optimal brain function and also contributes to delayed brain aging. And what this really means is that vitamin D supports the growth of nerves and also new synapses between neurons, what's more commonly known as brain plasticity. And the area of the brain where the vitamin D receptor proteins are the strongest is in the hippocampus, which is critical for learning and memory. Also, pertaining to vitamin D's specific effect on brain injury inflammation, vitamin D modulates microglial activity and neuroinflammation while inhibiting the injury-instigated activation of the inflammatory nuclear factor kappa B pathway and its numerous inflammatory cytokines. Vitamin D is also a natural anticoagulant, so in this capacity alone, vitamin D helps to reduce the possibility of post-injury blood clots in the brain. Brain trauma of any kind rapidly accelerates vitamin D deficiency and also decreased expression of the hippocampal vitamin D receptor. So that's one reason among many why you should take some supplemental vitamin D daily, because regular intake of vitamin D both restores the activity of the hippocampal vitamin D receptor while also promoting hippocampal neuronal survival and overall cognitive recovery. Another area where vitamin D is of particular benefit is through its reduction of cerebral swelling, also known as brain edema, which is something that almost always follows a traumatic brain injury. And this is why cerebral swelling is sometimes even referred to as secondary brain injury. Again, regular intake of vitamin D can sharply reduce the progression of post-injury brain swelling. Once again, you absolutely need to pair your vitamin D with magnesium to activate the vitamin D properly, but independent of vitamin D, magnesium is itself essential for brain function. Specifically, as magnesium facilitates neurotransmitter function, modulates the stress response, and also, like vitamin D, positively influences brain plasticity, which is important for anyone, whether they've had a brain injury or not, because, as we all know, our synapses gradually degrade and lose plasticity as we age anyway, which definitely impacts cognitive function. Magnesium slows this synapse degradation. There's even a form of magnesium known as magnesium l-threonate, which easily crosses the blood-brain barrier and is consequentially the most qualitative form of magnesium for the brain. And you can find magnesium l-threonate either by itself or as part of a complex with other more general preparations like magnesium glycinate and or taurate. Additionally, if you're taking your vitamin D with magnesium, then you should also pair both with some vitamin B6, also known as pyridoxine, because B6 dramatically enhances intestinal magnesium absorption while also being a required cofactor for the synthesis of numerous neurotransmitters like serotonin and dopamine. And this is why depression, psychosis, and poor short-term memory are all signs of a B6 deficiency. Remember that vitamin D is fat-soluble, so look for it ideally as either a soft gel or even a fat-based liquid. And as for a general daily dose, try taking around 5,000 IU with 500 milligrams of magnesium, or even a much smaller dose of both several times each day. Thanks for watching. I'm Jason Carter, and I'll see you next time on ENZYMENTAL. Stay healthy.